Okay, so I had sent out a notification on Remind asking everyone to send me their questions on this volumes packet. I got a grand total of one response asking me for numbers 7 and 8. So that's what I'm going to do for you here. All right, so number 7, the water tower. Okay, so the picture's a little hard to see, but the water tower is basically in the shape of a cone on top, then a cylindrical body, and then a hemisphere on the bottom. Okay, so we got to find the volume of all three. Okay, they're all basically circular figures. Okay, so we need a radius for each one of the formulas. If you look closely, this 8.5, the radius of this hemisphere, is the radius of all three circular figures. 8.5. Okay, that means this distance is 8.5, and this distance is 8.5, and that one's 8.5, and that one's 8.5. All of the radii for the figures we need to calculate are 8.5. Okay, so keeping that in mind as we go forward, because we need those for each of the formulas. Okay, so the first thing is the cone. Well, the cone we know is 1/3 the area of the base times the height. So we need to know the height. The height of this cone is ED right here. Okay, we know this angle is 47. We know this is 8.5 in here. So using trig, we can find that side. Opposite and adjacent is tangent. So I'm going to take that over here. I'm going to say tangent of 47. Tangent of 47 equals x over 8.5. Okay, cross multiply and I get that x is going to be 9.11 units. Okay, so in that case it's feet. 9.11 feet is the height of the cone. Okay, so the volume of the cone is 1/3 pi r, which was 8.5 squared, times 9.11. Okay, that will be the volume of the cone, which is 689.26. Remember, I need to take my rounding out to a couple more decimal places to make sure I got the precision that I need. So that's the cone. Okay, let's see. Let's go back to here. That's the cone. Now the cylinder. Okay, the cylindrical piece also has a radius of 8.5 and a height of 20 25 feet. Okay, 25 feet is the height. Okay, so we know that the area of the cone, sorry, area of the cylinder, volume of the cylinder is going to be pi r squared h, which is pi times 8.5 times 25, okay, which is going to equal 5674.5. Okay, that's the volume of the cylinder. Okay, the hemisphere, we already know the radius of the hemisphere is 8.5. So first of all, a hemisphere is going to be half of a sphere. So I can do it this way. The hemisphere is going to be 1/2 of 4/3 pi r 8.5 cubed. Okay, so then that's going to give me, if you figure all that out, 1286.22. Okay, so we add all those together. The total volume of the water tower, the total volume, if I add all those numbers together, is going to be 7649.98, rounded to the nearest cubic foot, is 7650 cubic foot for the total. Okay, so that's the first part of the question. Okay, part A. Just adding those three pieces together. Okay, and we just needed to use a little bit of trig to get that to get that height of the cone. Right now, it's constructed to hold a maximum of 400,000 pounds of water. Water weighs 62.5 pounds per cubic foot. Can the water tower be filled to 85% of its volume and not exceed the weight limit? All right, so we need to find 85% of its volume. So I'm going to take I can do it this way. I'm going to take 7650. I'm going to take the entire volume and multiply it by 62.4. That would be the entire volume if the entire thing was filled up. That would be the total weight if it was completely filled up. And I'm going to take 85% of that, so 0.85. Okay, and when I multiply all of that out, that gives me 406,405. Okay, so the answer is no. They better not fill that thing up more than 85% because it's much heavier than it was built uh, to hold. Okay, so the answer to that is no. Okay, so that's that one. Okay, so moving on to number 8. Number 8 looks like this: a water cup in the shape of a cone has a height of 4 inches. So this is kind of like a truncated cone question. Okay, we've got a cone that looks like this. Okay, its height is 4. Okay, its radius is 1.5, right? Because the diameter is 3. Diameter is 3, so the radius is 1.5. Okay, so I'm going to look at this as a right triangle in here. We want it filled up to halfway. Okay, so now this cone in here has a height of 2. Okay, and I can figure out the radius of that. Okay, so I can build a proportion again using this right triangle, these two triangles, this little one here, this little one down in the bottom here, and then the big right triangle are similar to each other. So I can build a proportion big 4 over 2 equals 1.5 over x. So 4x equals 3. So x equals 3/4, which equals 0.75. Okay, so the radius of the small cone is 0.75. All right, so I know the volume is 1/3 pi r squared h, 1/3 pi, 0.75 squared, and the height of the small cone is 2. Okay, and that is going to give me a number of 1.17. This equals 1.17, rounded to the nearest tenth is 1.2. Okay, so that was our answer is number 1 here. Okay, nearest tenth of a cubic inch. All right, so that's it. Okay, so hope that's all your questions on that packet, and see you next time.